Good morning, good afternoon, good evening, everyone. My name is Nate, and welcome back to another weather forecast discussion for February 13th, 2022. Happy Super Bowl Sunday, everyone. I'll just go ahead and get rid of the give it to me straight question of the day here. Get that out of the way in the beginning of the video. Who do you think's going to win if you're going to watch, and what are your score predictions? Please leave a comment down below with your thoughts. I'm really interested to see what you guys have as your predictions, because this is going to be a really interesting one if you're watching, but if you're not, if you're not into football, that's fine too. Enjoy your Sunday, everyone. As for our own predictions here in the world of atmospheric science, we still have our severe weather event that is more than likely going to occur on Wednesday into Thursday, and it could be pretty widespread for the southern portions of the United States. Now, this video is going to be done a little bit differently than we typically would, so if you guys would bear with me, then feel free to learn a thing or two, but otherwise, please be sure to like the video so we can spread this information with as many people as possible. Subscribe if you're new, turn on notifications to stay up to date with every single video that I'll be uploading all the way up until the event, and then we will be live streaming this event as well, so you do not want to miss that either. And let's get straight into it here with the satellite imagery to try and understand what the general flow of the atmosphere is. We got a couple interesting things here. First off, we have our Alberta Clipper that is going to start to surge on through and create some sporadic snow showers across portions of the Great Lakes and the southern portions of Manitoba and Ontario. That'll eventually clip on through and move towards Quebec in the northeast, but it's not expected to bring a whole lot of snow for those portions. So just basically a general dusting similar to what the mid-Atlantic had last night. And on the other hand, you can see a big dip in the jet stream right within here, this massive trough that is surging off on the coast of the eastern United States. And then you have this massive ridge here that is basically moving further and further inland. And that's going to basically create a window of opportunity for this low pressure system that's just barely up there. You can barely see the counterclockwise flow, is going to start to surge on through and buckle down and then eject through the central portions of the United States, creating some heavy amounts of snowfall in the north, as well as ice accumulations, and then some severe weather that does include the potential for tornadoes within the south. So we're going to have to see how this plays on through, and we can take a look at that with the weather models here. Alrighty, so if you want to keep up to date with all this, the date and time is above me, and we're taking a look at the 500 millibar wind shear, which is just basically as if you had that satellite imagery that is imprinted over here, and it tells you how fast the winds are. So we're looking once again at the 500 millibar wind shear level, which is about 6 kilometers above ground level. And you can see that massive dip in the jet stream that we were talking about with our big ridge that is starting to develop in towards portions of the western United States with that big high pressure system that is now starting to move further and further inland. So let's play this on here from Sunday into Monday and Tuesday, and boom, you get that big low pressure system that starts to move from the Pacific Northwest. It'll create some showers and thunderstorms, maybe even some snow across portions of the higher elevations of British Columbia, Washington State, Oregon, that general vicinity. And then as this low pressure system continues to deepen on further and further, this is expected to move on through into portions of the central and eastern portions of the United States, creating some significant wind shear. But you see how that low pressure system kind of just fades away. It turns into this massive boundary more or less, and it's basically going to shear itself out a bit. So by the time it gets to Friday, the significant amounts of severe weather more than likely will start to deteriorate, and we'll have a 2-day window of opportunity for severe weather that'll really be, it could have the chance to potentially be significant. But for the time period here, as long as that low pressure system continues to stay alive, you can see how it kind of buckles right within here. And you can see that that's barely where the low pressure system still exists. As long as that's there, it will still have severe weather, but then you can see how it moves from Thursday into Friday. It starts to shear out completely, and it'll be more of a strong damaging wind risk even after that. Now let's take a look at a couple levels lower to the 850 millibar wind shear level, which is about 1 kilometer above ground level. And you can see a couple things. You can see the clipper that's going to move on through, creating a lot of wind shear. It's also going to bring a lot of cold air behind this as well, so it'll be a little bit of a cold air intrusion towards portions of the Midwest and the plains. But then look at this. Things get really interesting here as we get a new low pressure system that develops across portions of the prairies in Canada, and that'll kind of move on through. That'll create some snow for portions, once again, of the prairies, upper plains, upper Midwest, into portions of the Great Lakes. You guys could get quite a bit of snow within that general vicinity. Not exactly a significant amount, but definitely some heavier amounts of snow to where visibility could be relatively low. And then that developing low pressure system down over here into the southwestern portions of the United States could create some significant wind gusts over here across much of these areas here in California, Nevada, Arizona, even towards portions of the Baja California peninsula in Mexico. This is where the developing low pressure system is really going to start to kind of fire off. And then as this continues to move on through, you can see wind shear really starts to amplify across the board here from Wednesday into Thursday. And the thing of it is here is you kind of notice how if we go back a couple of hours, you can see how the wind shear is not as significant. And that's going to play a role here because you have a lot of moisture over here in the Gulf of Mexico. And this wind shear here is going to pick up that moisture and actually bring it across into some of these areas to where we could potentially see severe weather. But because it's not super significant at this time, that moisture is not going to be moving very quickly into the area. So some areas to where there could potentially be severe weather may actually lack it a little bit due to the fact that there won't be as much moisture within the area. But then, of course, as it starts to transition into Thursday, that is definitely not the case. You can see how significant the wind shear is across the board, and we can attribute this to potentially a rise in severe weather on Thursday. And we can actually see this process if we compare two models here real quickly. We're going to use the NAM model on the left and then the GFS model on the right. And this will basically show you how there will be a little bit of a delay into where the moisture will start to kind of rise through. You can see how it does so, but that really rich 60-degree moisture that you need from your dew points in order for you to get some substantial severe weather within the area is either confined into a small little area right here, or it doesn't actually get up into the area until much later on into the late evening hours and even overnight hours from Wednesday into Thursday. So you can see how that plays out further and further, and it just doesn't really get up there. I mean, it's really hard to say as to whether or not there will consistently be severe weather, but I'm watching for a little bit of a pocket right here. You kind of see how there's a little bit of an indentation that leads into portions of Lawton, maybe even Wichita Falls. That general vicinity right there, if a low pressure system actually does route, like what the North American model is saying, which is pretty good with convective activity for the most part, then we could potentially see some supercellular activity right along the dry line right there, which is just basically where the difference between very, very high dew points and very, very low dew points actually exist. And so we have rich moisture towards the east and very dry air towards the west. That is your dry line right there, and thunderstorms typically form right along that. So if you have a lot higher moisture within that area, probably I'd say up into the 60s, you guys will definitely get some activity around your area on Wednesday night. So let's start timing this out here with the Euro model. Taking a look at the simulated reflectivity, you can see how that low pressure system over the prairies really starts to deepen, 994 millibar pressure as it gets into Ontario. And then this is when things start to get really interesting. The 998 or the 988 at this point millibar low pressure system, golly, is starting to kind of try and connect up with the low pressure system that is trying to form and trying to create some severe weather for portions of the south. But you can also see on the northern end of that boundary right there, the Arctic boundary does actually create some freezing rain and snow across some of those areas. So not exactly just a sole severe weather event. You guys are also seeing some wintry precipitation with this. And of course, if you've been on my channel for quite some time, you know how detrimental freezing rain could actually be. So if you live within some of these areas here of northern Missouri, extreme northwestern portions of Illinois, down into portions of southern Iowa, you guys really need to watch out for some potential heavy freezing rain amounts. And even as you get into portions of central and northwestern portions of Indiana, you guys could potentially get some activity as well. But you can also see how deep this moisture, all this rain actually is down here in the deep south. So don't forget about you guys either. It is a double whammy of weather as this continues to move on through, and even in portions of central Ohio into portions of the northeast, you guys could probably get some winter activity as well as this pushes on through. So definitely something to where everyone's going to have to continue to watch out for this. Practically if you're from Kansas and Missouri and further eastward, as well as from Oklahoma and Texas eastward. All right, you guys could more than likely get some form of weather activity. So how much weather activity, you may ask? Well, let's say about 3 to 5 inches of snow across this band right here. That does include portions of St. Louis down towards portions of Wichita, Kansas, and even to portions of northern Oklahoma. You guys could potentially get some snow after the potential rain showers and even severe weather that could move on through into your general vicinity. You can also see how much snow is across portions of the prairies as well. 3 to 5 inches of snow is possible. And then this is when things really start to get interesting. As you head towards Ontario, portions of Quebec, near Quebec City, Montreal, Ottawa, and stuff like that, you guys are could potentially get a plethora of snow across your general vicinity, almost 2 feet of snow according to the Euro model. So we're going to have to continue to watch out for how this continues to progress. Of course, I'll keep you guys up to date as this moves on through and gets closer and closer to the actual day in question. And then, of course, if we shift over towards the freezing rain, well, you can see you have some hefty freezing rain amounts around the general area of St. Louis, even in towards Columbia. You guys could potentially get a lot of freezing rain within your general vicinity. And it's just one of those things to where you're going to have to continue to monitor this as we get closer and closer. It's not exactly set in stone quite yet, but the potential for some significant freezing rain is possible, and you can see the maximum at the bottom right-hand corner. It's over an inch of freezing rain within that general vicinity, according to the Euro, and it only takes, fun fact for people, it only takes 3/4 of an inch of ice for an NHL ice surface to actually be good enough to be skated on for an actual NHL game. So this is NHL ice rink worthy amounts of ice that is potentially possible across some of these areas. So something to where we're going to have to continue to monitor them. So now this is the different way that I was talking about in the beginning of the video, that I was going to start approaching severe weather. And instead of showing you guys Cape and all sorts of other stuff, I'm going to just show it to you here on the photographs and the QT charts. And you guys might be looking at that and thinking I'm speaking a whole different language. And to be completely honest, you're kind of right, but we're going to start to just kind of look at this step by step. And we're going to first take a look at this thing right here, what seems to be a slinky that has been bent in all sorts of different directions and needs fixed. And in this case, this is your photograph up here. This takes a look at your wind shear with height as well as your direction. So the big thing here to look out for is that this red line here, if it starts to curl to the right, that's when you know you have some veering with height that is favorable for supercells in the atmosphere. And you can see I put a picture up there into the top left-hand corner of that, and it kind of shows you a little bit of a curl right there. You can see how it has a bit of a hook characteristic. Well, that photograph right there from the 0 to 3 kilometer range also has that little hooking characteristic. So we do have some veering in the atmosphere. It's just not a whole lot. It's relatively weak for the most part, especially as you get towards the 2 kilometer range. You can see the little 2 dot right there. That is 2 kilometers above ground level. And of course, it's also in the middle of its storm motion if it is rooted in the atmosphere. So we might see a little bit of a high precipitation type supercell here if things do form. But if we head over to the QT chart, which tells you as to what your thermodynamics is in the environment, tells you what your energy levels are in the environment, it doesn't really show a whole lot. As a matter of fact, the CAPE numbers down here, you can see that the SFC is surface, and right next to it is 479. That is how much CAPE there is in the atmosphere. And if you guys remember, well, you need quite a bit of CAPE, about 1,000 joules per kilogram of CAPE in order for you to get some form of severe weather within your general vicinity. And I'm not seeing a whole lot of that according to the NAM model here for the most part. Although we do have some interesting capping inversion that could potentially limit this environment, but I don't think it's going to be that big of an issue, to be completely honest with you. I think the boundary is going to move on through. It'll start to alleviate this capping inversion right here that is basically limiting lift in the atmosphere. If you think of capping inversion as your opposite for CAPE, so CAPE is your energy levels. It's kind of like having, Batman and the Joker, right? It's completely opposite of each other. You have the villain and you have the hero. The CAPE is technically the villain, and the capping inversion is the hero to stop thunderstorms. And so in this case, it's preventing the lift from the atmosphere. CAPE is warm air rising and cold air sinking. So if you have a bigger displacement between the two, that can indicate into some higher CAPE levels. But if you have something to where you have a lot warmer air above some warm air, that warm air at the bottom won't rise at all. And so that's what we have here in the environment. We have a little bit of that, but my thing here is that I don't think this will limit it all too much. I do think we'll get some showers and thunderstorms that'll start to move on through and potentially become tornadic. It's just how much energy there is in the atmosphere for this thing to continue to move on through. And then the other thing here that I want to mention is that you see this green line that moves on through. At the bottom, it says a number of 59F, and that's 59 degrees Fahrenheit as your dew point. So the green line there is your dew point. Your red line there is your temperature, and we do have some relatively high dew points, at least for this this time frame here for this event. right over here, and I did take this sounding a little bit further towards the north and west of Dallas-Fort Worth. Somewhere, I'm looking over at Google Maps towards the Bowie, Jacksboro area, maybe a little bit further to the south and east of Wichita Falls. So somewhere within that general vicinity, north of Weatherford, that's where I got the sounding from. So it's kind of a decent environment here at 21Z, which is sometime around the afternoon to the evening. If we shift over here towards 0Z, I took this sounding over here. It'll be a little bit discombobulated, but you can see the square at the top left-hand side. You can see the outline of Oklahoma, and it's right near the Lawton, Oklahoma general vicinity near Altus as well. And so you can see the environment here, a lot better defined photograph here. It's still not really, blowing me away at any instance, but it is a lot better defined and a lot more conducive for supercellular activity, which can produce tornadoes. Of course, you also take a look at the CAPE values over here, and you can see the FCST, that's your forecast CAPE, and it does get above 1,000. It actually gets almost to 1,400 joules per kilogram, so that's still something to watch out for as well. And then the other thing here is that you still have your cap inversion that you can see that goes over that dotted line. So if you ever see it to the right, that's your capping inversion. When it goes to the left, which is over here, that is your CAPE. So if you see a lot bigger distance between the dotted line and your red line, you indicate more CAPE in that instance. And so we do have quite a bit of CAPE here, and we do have some strong wind shear across the board with storm relative helicity values from the surface to 1 kilometer, about 210 meters squared per second squared. So definitely something interesting within this area. According to the sounding, I do think that you guys could see some supercellular activity, and I think that's going to be relatively consistent as that moves on through. And we mentioned how if there's more moisture that moves off into that general area, then there definitely could be some more of that activity where that came from. But the GFS paints a completely different picture. It's the same area here to where we took this sounding. It's actually a little bit further to the south towards the Wichita Falls area. So different model, different perspective. And they think that that capping inversion is going to be a lot more significant. You can see over here, the CINH gets to a negative 185, and that is well above what you need to just completely make an environment just die out. No severe thunderstorms, according to this sounding, probably will form unless if you have a heavy confluence band, which that's not expected to move on through until a lot later on in the evening. So that's definitely something to watch out for that. If the GFS is correct, probably not going to get a whole lot of showers and thunderstorms with this system. If we shift over here towards Arkansas, right, I took this sounding. You can see at the top right-hand side right here. Right here, the southwestern portions of Arkansas, near the Texarkana general vicinity, maybe even a little bit further towards the north and east of Texarkana. And it's a lot better defined photograph. You can see how the photograph actually expands a lot more. It's a lot larger, and it's a lot more of a hook shape. And whenever we see that, that is one of those signs to where the wind shear in this environment is relatively significant, and we could potentially see some supercells within this general vicinity, given it has enough energy with that. And we do have forecast CAPE. Eventually, it will get up to 1,400 joules per kilogram. So that's something we're going to have to watch out for, all right? This is overnight southwestern portions of Arkansas around 9Z. Which is about the midnight, so a little bit past midnight hours, sometime around 2 o'clock in the morning within that general vicinity. So some overnight showers and thunderstorms that could be supercellular, could create tornadoes. Definitely an issue that I see. It'll be a lot more of an overnight threat. I mentioned a confluence band that'll move on through that basically just channels a lot of that moisture. And if you have a lot of moisture that is being channeled within a short specific area, you can get a lot of convergence. Convergence can create showers and thunderstorms. And if those showers and thunderstorms get significant enough, they can even produce supercells or become supercells and eventually produce tornadoes. So you got that within that general vicinity. And then if we shift off over here towards Thursday, I took this in the general vicinity of southern Mississippi, but I also see this a little bit towards the border of Mississippi and Alabama, near the Meridian areas, and further south towards the Waynesboro vicinity. You guys are definitely seeing the same thing, maybe even a lot more CAPE potentially for your area, but a very big looping hodograph, or not exactly a big looping hodograph, but a decently big looping hodograph for your general vicinity, as well as some decent CAPE amounts forecasted to be over here within about the 1,700 joules per kilogram range. I'm expecting that to get a little bit larger. I think as we get closer and closer with the North American model, the North American model can't actually reach this general vicinity quite yet. It only has a grasp as to what's going to happen on Wednesday. So I think that this is definitely going to be a lot higher. I think the dew points are really good. I can see the boundary level, or the boundary is going to be moving on through this general vicinity as well. And as I said, looping hodograph right within here, it is favorable more than likely for supercells to produce tornadoes within that general area. So I'm just going to have to continue to watch out this for you guys. I'll continue to do this as we get closer and closer towards the actual event here. But for the most part, I appreciate you guys coming out to the video. I know this was a little bit complex as we got towards the end of it, but thank you guys so much for watching. And if you did enjoy it, please be sure to leave a like, subscribe if you're new, turn on notifications, share this with friends and family and on social media. Also follow me on social media. Link will be in the description down below. If you have any questions, feel free to leave them in the comments. I will try to answer them as best as possible. But otherwise, have a good Super Bowl Sunday, everyone, and I will catch you guys on Monday night. Peace out, everyone.